Before we begin, we would like to acknowledge that Dalhousie University is on the traditional unceded territory of the Mi'kma'ki people. This experiment took place at Point Pleasant Park, and we are grateful for the opportunity it allows for students like ourselves to conduct scientific research. Now, Juan blew it, nature grew it. Point Pleasant Park's secondary succession since 2003. Point Pleasant Park, also known as Amntu'kati, is a beloved and historically significant urban green space in Halifax, Nova Scotia. Established in 1866, the park has a rich history, including its use as a spiritual gathering site for the Mi'kma'ki people, as it was known as the Spirit Place or the Place of Spirits. It occupies 75 hectares at the southern tip of the Halifax Peninsula, thus making its location particularly susceptible to coastal weather patterns. The park's vegetation is largely representative of the Acadian forest, a forest region characterized by a mix of coniferous and deciduous trees, including red maples and red spruce. Although in 2003 disaster struck and the park was hit by Hurricane Juan, a Category 2 storm with wind gusts up to 185 kilometers per hour, the hurricane left the park in rubble, destroying 70% of the trees in the park. Now, here are some key points for you to understand the rest of the presentation. Secondary succession. Secondary succession refers to the ecological process where a disturbed ecosystem recovers, but unlike primary succession, it occurs in an area with existing soil and remnants of previous life. The Shannon Diversity Index is a measure of species diversity that takes into account both the number of species and their relative abundance. Species richness is the number of different species in a particular area. Species richness is one of the factors that contribute to the measure of diversity. Species evenness is a measure of the relative abundance of different species in a community. And finally, a climax community is the ultimate stage of ecological succession, where the ecological community reaches a steady state. The objectives of our research project are the following, and below each question you can see both null and alternative hypothesis. Number 1. How has the overall forest community changed over time, and why? What can you predict will happen to the overall community as the forest moves towards its climax community? Number 2. How has the density dominant species in 2004 as well as the dominant species in 2024 changed over time, and why? What can you predict will happen to the dominant species as the forest moves towards its climax community? And finally, how has the Shannon Diversity Index changed over time, and why? What can you predict will happen to the Shannon Diversity Index as the forest moves towards its climax community?
All data was collected each year from the same forest plot or study site since 2004, except for the years 2005, 2007, 2016, and 2020. The study sites were decided based on where the hurricane had highest impact. Each site in Point Pleasant Park would collect 5 metrics of data after the impact of Hurricane Juan in 2003 to be able to get quantifiable numbers. These metrics were total density, richness, diversity, max diversity, and evenness. Excel was used to gather and calculate the sums of the 5 metrics of data from all 6 sites over the span of all 20 years. This provided the information needed to perform regression analysis. The average size of tree per site was then calculated after the density calculations. Size played a significant role, as if the tree hadn't reached a certain diameter, 2.5 centimeters, or a certain height, 4.5 feet, it wouldn't be counted in the total abundance. The total densities were used to then find 2 additional resources, Shannon diversity and the evenness index. A regression analysis was then created using this data. A scatter plot was used instead of a line graph, as there were multiple sites for every year, and within each year those sites didn't rely on each other. Therefore, it couldn't be an independent dependent variable. The graph's data sets were then run through RStudio to create a stats datasheet, as well as guaranteeing the graphs were accurate. Linear regression was used in the research to find a linear correlation between the dependent variable, which was tree species density per 400 meters square, and the independent variable, which was years from 2004 to 2024.
A linear regression analysis was used to analyze the succession of total density of trees in Point Pleasant Park, Halifax, Nova Scotia, after the impact of Hurricane Juan in 2003. These measurements were gathered from 2004 to 2024 by Biology 2060 students across 6 Point Pleasant Park study sites created in 2004. There is a significant positive relationship between total density and time, where 49% of the variation in total density is explained by time. Because of the significant change in tree density, the null hypothesis is rejected. From 2004 to 2024, the overall forest community has increased in total density over time, being the highest in 2050 at a density of 283 per 400 meters squared, as seen in Figure 1. A study by Burleys in 2008 found that hurricane disturbances often cause the restoration or more rapid recovery of ground vegetation. This supports the increasing trend in Figure 1, as it is an example of secondary succession in Point Pleasant Park post-hurricane. After the cleanup of the hurricane, it was seen that 89.1% of the ground in Point Pleasant Park remained undisturbed or showed no visible signs of traffic, exposed mineral soil, or erosion. This preserved ground condition would influence ecological succession in increasing in total density, as most of the area was still suitable for tree growth and natural regeneration. As the forest moves towards its climax community, we can predict that the overall growth of the forest will slow as it reaches equilibrium. Initially, plants like grasses and shrubs will colonize the area and then give way to pioneer trees that tolerate high levels of light. Over time, the slower-growing shade-tolerant species will outcompete the early successional species as the canopy closes and there is less light available.
The linear regression was used because it helps to identify whether the variable of density is increasing or decreasing over time in Point Pleasant Park. This linear correlation illustrates that the density of the spruce tree has fluctuated over time since Hurricane Juan hit in 2003, but does have an overall increase, as the final plot in 2024 has a higher max density than the first plot in 2004. Although the regression value is quite low, it is still statistically significant but weak increase of tree density in the spruce tree. Therefore, I fail to reject the null hypothesis. A linear regression was used to determine the succession of density of maple trees in Halifax, Nova Scotia after Hurricane Juan hit in 2003. Dalhousie students took surveys from 6 different sites from 2004 to 2024. During that span of time, the linear regression line does show an increase in forest abundance and density of maple trees, though not at a super fast or strong rate. This is indicated by the regression value of 0.1549 from Figure 3, as well as showing a weak but statistically important relationship between dependent and independent values. Therefore, I fail to reject the null hypothesis. The experiment was done to have quantitative results on how much effect secondary succession had on Point Pleasant Park after the hurricane in 2003. Figure 2 and Figure 3 was specifically created to identify if the dominant species in 2004 versus the dominant species in 2024 changed noticeably over time. Dalhousie students obtained data in 2004 from 6 sites in Point Pleasant Park. As well, each site had been studied for 20 years, which allowed for much data to be collected and compared. Based on both graphs, it is visible that once the species reached its optimum, its correlation lowered back down, though not as decreased as the density was in 2004. Both species are being studied as they are both directly affected by the hurricane. These 2 species are the red maple species and the red spruce species. The red maple species, which is Figure 3, shows a regression increase of 15.5% of total density in 2024 compared to 2004. As well, the red spruce species, Figure 2, shows a 12.3% increase of total density from 2024 compared to 2004. Based on the results of the experiment, I would come to the conclusion that the spruce and maple species do end up dominating over other species in Point Pleasant Park.
A regression analysis was conducted to better understand the succession of the Shannon Diversity Index of Point Pleasant Park post-Hurricane Juan in 2003. The regression equation for the Shannon Diversity Index was found to be r squared equals 0.3352, y equals 0.0606, x minus 120.85, with a positive slope of 0.061, suggesting an overall increase in the Shannon Diversity Index since 2004, which supports the alternative hypothesis. These findings align with the ecological succession theory, which predicts that diversity increases in the earlier stages of succession following a disturbance, as pioneer species colonize the area and create conditions for more complex communities to develop. The initial decrease in diversity post-Hurricane Juan can be attributed to the catastrophic loss of the canopy cover, which disrupted the existing community structure. However, the subsequent increase in diversity demonstrates the natural regeneration process where early successional species began to dominate the landscape. The positive slope of the regression line indicates a gradual but steady increase of diversity over time. The trend is also consistent with studies in other temperate rainforests that are in post-disturbance recovery, where diversity tends to peak in early to mid-succession before stabilizing as the forest matures. These studies support the idea that the Shannon Diversity Index in Point Pleasant Park is following a typical successional trajectory. Furthermore, the stabilization of diversity as the forest approaches its climax community is consistent with the findings of Burley et al., who noted that the regeneration process of Point Pleasant Park was dominated by native species with minimal invasion by non-native plants. This suggests that the park is progressing towards a stable, mature forest community where diversity levels will likely plateau. In summary, the regression analysis of the Shannon Diversity Index in Point Pleasant Park indicates a clear pattern of recovery following Hurricane Juan. The initial decrease in diversity due to this disturbance was followed by a steady increase as pioneer species colonize the area, and diversity is expected to stabilize as the forest matures. This pattern aligns with the ecological succession theory and is supported by studies in other forest ecosystems, reinforcing the validity of the observed trends in Point Pleasant Park.
Based on our data and succession theory, Point Pleasant Park is in the mid-successional stage following Hurricane Juan in 2003. This stage is marked by grasses and small shrubs colonizing the area, while shade-tolerant species have not yet become the most dominant in the area. As succession continues, these species will outcompete early colonizers with increasing canopy cover. Being an urban park, Point Pleasant Park faces challenges to succession. Human traffic compacts the soil, making it more difficult for seedlings to establish and contributes to habitat disturbance. And anthropogenic pollution from runoff and air contaminants may alter soil fertility and slow the growth of mature forest species. Integrating indigenous knowledge, such as the Mi'kmaq principle of two-eyed seeing, would strengthen restoration efforts by combining scientific and traditional ecological approaches. Indigenous teachings emphasize biodiversity and stewardship, creating a reforestation strategy that aligns with natural processes and long-term sustainability.
We would like to acknowledge that Dalhousie University is on the traditional unceded territory of the Mi'kmaq people. This experiment took place at Point Pleasant Park, and we are grateful for the opportunity it allows for students like ourselves to conduct scientific research. We're also very thankful for Alice and Max for organizing the lab and allowing us the opportunity to learn about succession with real-world example. We're also grateful for everybody currently in, as well as everyone who has been in BioL 2060 in the past 20 years, for gathering information and data for this experiment. And lastly, we're appreciative of all the effort put into this presentation by each group member for making this presentation possible.